Good afternoon, everybody. Thanks for joining our clips for the symposium. Today, I'm very happy to have with me Anders Jensen, if I pronounce this correct. Anders is the executive director of one of our brothers or sisters joint undertaking, the one on high performance computing. In his previous life, he was IT responsible in NATO, if I am correct. I think a very responsible job at that time. Anders, welcome. We have had already a lot of discussions on many different topics, and I'm sure for the benefit of the audience today, although we are like brothers or sister joint undertaking, can you explain in 3 words or 4 words the high performance computing joint undertaking? What specifically is your mandate? And what are the key differences from the KDT joint undertaking?
Yeah, thank you, Bert, and thanks a million for the invitation. I think this is really it's really welcome. So yes, we're EuroHPC joint undertaking, and you say what's our mission? Well, it's twofold. On one hand, we are procuring and building up a network of supercomputers for Europe. So these are machines that the joint undertaking that we're procuring and that we are going to be operating through hosting entities, and the compute capability of those machines will be made available to researchers and public sector in Europe. And then in parallel to that, we have a research agenda where we are going to be supporting, and we already are supporting, research and innovation through grants in a similar fashion as Excel is doing for components. So I think if you look at it, we are very alike, but the EuroHPC has this additional element of procuring equipment, machines, and operating them, making them available. Something that I don't believe you've had the pleasure to do yet in Excel. So that's the additional challenge. But other than that, when we're looking at going out and promoting research, and our job is to create state-of-the-art HPC technologies for Europe, and you're doing similar stuff on components.
Yeah, I know. Thanks, and I think many of the audience today and people in our community are very familiar with computers. Yeah, but what makes a computer a high-performance computer? If you can tell me that.
They're faster. No, joking aside, I mean, here we are really talking about equipment that takes computers to another scale. This is to put things into perspective. One of the smaller machines that we've acquired and that has gone that is now operational in Slovenia basically includes 1,000 nodes, 1,000 compute nodes, that each of them has more electronics than most of the servers that you would be installing in your basic data center. So the computing power we're talking about in the supercomputers is vastly beyond what your normal computing infrastructure would be providing.
All right. So basically, it's a multiplication of the conventional technologies, and obviously, we have been working already for some time. Excel has been working already for some time on everything related to processors, silicon-based processors. So we have already a lot, let's say, to serve you. For you, yeah, and for the full HPC community. So synergies are pretty obvious between our both joint undertakings. So from the, let's call it, technical side, yeah, what do you reckon? What do you see as obviously technical synergies between our both joint undertakings? How can we serve you? How can we serve you better? What do you need for making the computer, the high-performance computer, even faster?
So one analogy to high-performance computing is the Formula One for cars, in which you have basically Formula One manufacturers are testing new technologies. They are testing new ideas. It's costly, and some of that generates real products that eventually makes it into our consumer cars. In many ways, you can compare that with the HPC industry, where the latest and greatest technologies and chip technologies, memory technologies, so on, are being tested, this is where we push things to the limit. And then as the technologies evolve and as they become, what should we say, more cost effective, they make its way, the technologies make their ways into enterprise equipment or consumer equipment. And by the way, it's not just hardware technology. This is the same for a lot of it also applies to the software domain.
Mm-hmm.
So I think where we can work together, it's natural that we work together. We on the HPC side, we look to be driving some very specific niche components, but by working together, hopefully we would be able to already seed the idea that there's a market for it, for a broader use of and therefore making it more attractive for industry to get into the domain and to help us produce this European technology.
Right. So, can I ask, is this in the field of the normal? In simple terms, do you need the next generation of laptop computers, or do you look at new architectures like neuromorphic or quantum? What's your take on that?
It's very much across the board. We need the latest and greatest in many of the domains. You can say there's the fundamental processor, where we're working on the European Processor Initiative, but then there are all of the accelerators that links up to that. So neuromorphic for AI, we're looking at FGPA packages that would act as accelerators in the machine. There's a lot of drive for having specific components that are particularly good at solving particular problems connected to these machines, so that we can get the best performance and offload the general purpose hardware with using these accelerators. So accelerators in general, but it's also on the networking side. I mean, when you put this many compute nodes together, not only the speed but also the latency of the communication between each of the nodes is super critical. So memory bandwidth, the caching technology that would go into alleviate some of the latency on the main memory. All of these are fields that are being investigated within the HPC domain. Not all of them are being investigated here in Europe, and hopefully some of that will change over time. So yeah, any of these domains would be.
So you would be happy to be served from our side with the prime processors, whatever architecture we would come up with, if I understand correctly. But you mentioned also before, it's not only the hardware, but it's also the software, controlling, managing those machines. Is there on that side anything you could see which is, part of the scope of KDT you can be helped with from the operational point on the software side?
So I think within the area of software, and especially as you're much into embedded systems, there are a lot of aspects of. You also need on the embedded system side, you need to make things as efficient as possible. Normally, because you will have a limited hardware resource or a limited battery capability. That same efficiency, if put onto the HPC environment, makes the HPC run that much faster. So at the end of the day, an algorithm or a software stack, the more efficient that software stack is, the more we will be able to get out of the expensive machines that are the HPC machines. So saving 2% on getting 2% more compute power out of an existing machine is worth a lot.
No, I do understand, and you're touching up to a very critical and sensitive point at the same time. HPC computers, high performance computers, are energy eaters, energy consumers by large. Yeah. What, I'm not sure if that's our field of competency directly, but what do you see can be done on that side? I mean, from the energy consumption point of view, what is the biggest part of the energy consumption? Processors, memory, transfer, heating, cooling. What from that side is of interest and of use from programs like ours or others?
So the energy consumption of HPC systems is something that's very important to EuroHPC. There's very much a drive to not only have the fastest machines, but also in an energy-friendly way. Supercomputers will most likely always consume a lot of power, but limiting how much a lot is worth a lot. And essentially, so we are very in all of the decisions that's been made in and around the supercomputers that we've procured, energy and how the energy is delivered to the hosting entity has been one of the deciding factors. That is something in and around the greenness, if we can call it that, of the HPC system is key. Now, that's not only to consume less energy as such, it's also to require less cooling, which means we can have even bigger machines in the same space and so on. So it becomes a little, it becomes important from a number of angles, not just using as much power, but also actually being able to do more with the same power.
It's kind of a weird machine at HPC, because it's a cooling and a heating problem at the same time. No, on one side you're heating it up, and on the other side you need to cool it down because otherwise it's getting overheated. So I'm sure you have a lot of technical challenge in front of you, and feel free to call us whenever you need some help to sort out some of your problems, at least from the technical side. But also, I believe from the administrative side, I think we have a few elements in common. And recently we have had a discussion on what has been, how to say, proposed in the new regulations on as central management of financial contributions from the participating states. You have participating states, KDT, we have participating states. So what do you see as the main, let's call it, benefits or the advantage of this central management of financial contributions? Where do you see the main benefit of doing this?
So there is the potential of simplifying our lives. I've seen just in the short time I've been involved in EuroHPC that the co-funding and the management of the co-funding is complicated. Each participating state does things in a little different, with variations, and especially with different calendars. And some of that has, at least in EuroHPC, already caused some additional challenges, which the centralized management may be able to resolve for us, and therefore making our lives and the lives of the beneficiaries hopefully simpler.
I do agree, and although it's a complication, at least for the administrative side of the joint undertakings itself, I see the central management of financial contribution as a simplification for the beneficiary. And to be true, we're trying to put everything together. Yeah, what we do is to put the technology competence together. We put the different stakeholders together, the Commission and the member states. Yeah, and we put all the financial contributions together. So for me, this is a very idealistic model of building Europe. Yeah, we building Europe through KDT, through the high performance computing. You're putting money together, we're putting strategy together. It's complicated, but I'm sure we will try to work it out and to make sure it's going to succeed. Central management is a challenge. We have member states. We both working on processors, yeah, on computers. We have a lot in common. You're aware, yeah. When do we start doing something together? Yeah. How do we approach that? Yeah. When do we make our first call on the new processor type?
Well, I think that's up to us, isn't it? At the end of the day, I think there is a lot of potential for us working together, and it would be a shame if we don't grab it. The new regulation for EuroHPC is hopefully imminent, and equally your new regulation should also be there. So I think it's something we should start discussing. What is the potential? The different processor initiatives, I think, is an obvious one for us to at least have a discussion on how we might be able to join forces on that. And I think that would be welcomed across also in industry, because while HPC is an interesting field, the general consumer market is much bigger. So if we can find and therefore also the funding available and here I'm more thinking about the private sector funding to complement the project is more readily available if there's also a more general use of what comes out of what's being generated. So
yeah, triggers me two questions, Anders. Do you see from your side a direct spillover of the activities you're doing in HPC to the consumer markets? I mean, you cannot say HPC is a consumer market, but do you see spillover onto consumer markets, which may trigger a different field of let's say industries to be more interested in that?
I think the vision that was communicated around the European Processor Initiative, in which a processor that was developed for HPC purposes, because it was developed to be fast but also very efficient, would be used in consumer areas where particular high computing power was available or was required, was a really good one. And at the time, the idea was the automotive industry. As I understand it, the time it had, we're still not there yet, but the concept that we design, either we start from a more consumer or more consumer scale component, and from the HPC side, we add to it what it would take for it also to be a viable component for us, or the other way around, as it was visioned with EPI, we would have a really serious processor that would then be used in consumer products that would require high performance in an energy efficient way. I think that vision is spot on, and I think it could apply to many of the areas where we could cooperate, where there is because the HPC is achieved by taking the best breed of components, but then multiplying them, having so many of them. Well, imagine what you can just do with one. So I really buy into that vision, and I think there's a lot of potential also if we look at networking and so on, where what we need, just because we need it for a very specific mission, doesn't mean that it's not a good thing for a more generic mission.
No, very clear. And again, to simplify a little the things, you could say that the KDT, XL KDT has to work its way upwards towards more, how to say, more performing processors, whilst you could say that the HPC, the IPI, the EPI activity should work its way down towards more consumer market. And obviously we will find each other somewhere in the middle, yeah, and space for more synergies. Another question on the international play field, let's call it like this, yeah, politely. You have many different players on high performance computing. The Americans, the Asians, Chinese, yeah, the Europeans. We are not in the lead, if I may say. Yeah, that's clear. Which is very similar to what we experience in our normal ECS consumer electronics, yeah, consumer activities. To that, we have both a very similar problem. It's the international competition. Yeah, how can we catch back? Yeah, what would it need us to catch back on the advanced state of the latest Chinese supercomputers? Yeah, what would it take us? More money, more working together, I don't know, brighter ideas, new architectures. What is how do you see this, the international competition and catching back on that?
So in the HPC domain, it's clear there are multiple players, and not all of them are European. There's a really good collaboration and cooperation between all of the players in the field. I do need to point out, though, that there are areas where Europe is leading and bringing technology to the table. It's very much on the software side, it's in the application side, but also the cooling solutions. Some of the cooling solutions that are developed in Europe have actually defined HPC worldwide. So there's really some good stuff. I think the problem, to a certain extent, is money. For some of the technologies where we're lacking a bit behind, we've discussed processors. Processors is an extremely expensive hobby area to get into, extremely expensive, and therefore I think if we could, by joining forces there, we could hopefully and potentially broaden the interest of industry into getting into the field. If the potential market is more than just HPC for Europe, but but something that goes beyond that. It may be one way of getting back into that game, and similarly on other technologies. I think the fact is whether taking it from a niche to a broader market is at least one thing that could
the scaling up, the scaling or the application side. Yeah, very clearly. I know the international competition is an issue, but I mean the international competition, the international cooperation. How do you see that? I mean, I know the most well-known suppliers of HPCs are not Europeans. Yeah, the best, I can't say the best, the most used processors are at the moment not European. Do we make or do we buy them?
Well, I think it's a combination. At the end of the day, there's good collaboration. At the same time, I think we also need to catch up. We also want to catch up in a number of areas and be able to do things ourselves. I mean, if we look at the scientists who need the supercomputer, they will very much. They're very keen to have the best machine available to them for their applications to produce their results, and are less concerned about whether that is being done on an American processor or potentially a European processor, as long as the science that's being performed on top of the computer is, as long as the tool is delivering what they need. At the same time, we have a we have an industry and I think a need to also be able to, when required, to produce European technology, so that we regain a certain degree of self-sufficiency.
True.
It is interesting if we look at it. A lot of, especially on the processors, a lot of knowledge, and what everyone celebrates today with their mobile phones, what's inside there, I mean, originates out of Europe. So somehow we just wouldn't say we lost it, but we kind of did. There was a lot of knowledge, and there still is a lot of knowledge, but it's just not held in European companies, and therefore in European patents.
Now, it's true, and honestly, the telephone is a good example. There is a lot of a big share of European technology and competence in even the current telephones. Yeah, the packaging, is something we don't have our hands on anymore for different reasons, clearly. But to the end, and what you refer to also, the final user, customers, honestly, they don't care. Yeah, they don't care as long as it's functional, it's useful, it's practical. The customer doesn't care. But politically, it's very important. Strategically and politically, it's very important to have your hands on, to be, how to say, sovereign or technology independent for certain critical components. I'm sure that this will come on the future agendas of any discussions on how we see the instruments helping us to get a little more technology sovereignty in the digital world. Maybe one or two questions to wrap up and to finalize. We are both babies from DG Connect. You're aware, and we are more than happy about the, how to say, the support and we get from DG Connect. Because of that, because we both featuring under the umbrella of digital, joint communication, joint statements, joint talking is important. Small, medium, and big scale talking. What would be your thoughts about how to say? I mean, we have now our first, call it, seed planted. We can carry on doing this. How do you see any joint communication related activities coming up?
So I think for us to be able to work together on grants and so on, I think it's key that we also work together on some communication and perhaps some common events where we introduce our two sets of shareholders and partners to each other and the potential that's there. So I would very much welcome that. I think, as you correctly say, we're both kids out of DG Connect, and I think we can also rely on them to push us forward in such a direction. I mean, the digital day that's coming up now, I think, is a good example of DG Connect arranging an event in which we will then participate and continue to be also part of the communication framework of the Commission and in our case DG Connect.
Yeah, no, I think it's very true, and we should indeed how to say, support and support each other, support DG Connect, these kind of communication activities. And I think what is of crucial importance, I mean, we already have some kind of cross-fertilization done, but I think still we are not perfectly overlapping communities. Some of our members are joined, but not all of them. I think to get to know each other better from a community point of view, the HPC community and the Excel community, I think that's something maybe we can see as a target. Let's try to make sure we integrating better and we have better cooperation. So thank you, Anders, for replying to all my questions, but has been a little impolite. I've been asking the questions to you. Is there any question you would like to ask me on the Excel KDT community commission? Anything you want to ask me?
Well, thank you, Bert. I still have a lot to learn about Excel and KDT, but I would be keen to know, aside from processors and other good stuff we've spoken about today, I mean, what are your pet projects?
Our pet projects. Well, we have, of course, the technology development, yeah, and we going on the strongholds of Europe on power electronics. We go on SOI technologies, on lithography, on the different how to say stronghold on applications, mobility, and health and industry. I mean, this is what we are, how to say, strongly working on. But this is at the operation, call it the first level of operation. I think fundamentally we need to look at even a level higher, where we see on how, when we started Excel, we had the ENIAC community, the hardware, and the Artemis community, the software. And I think over the years, we have seen with the merge at the time Excel started to bring them both together, that this has been a right decision, and that process is still not finished. I think we need to integrate even further, how to say, the software and the hardware into a full integrated, applicable, useful system, to the extent that they are, how to say, perfectly interwoven. What you see happening now, honestly, the HPC is an example, neuromorphic quantum HPC, any processor, is and will be designed according to the software running on it, yeah, and the other way around. Yeah, the software will be designed to the hardware platform it's going to run on it to make it most efficient, especially energy efficient. Because honestly, the transfer of data is the most energy consuming part. Yeah, the processing itself is pretty simple; it all happens in the same. But shifting the data back and forth is complicated. And if we can start to integrate all this kind of how to say facilities features closer together, this will be more energy or less energy intensive, which I think is the main goal. Yeah, we have to prove how digital can become green, yeah, making technology, but also how the digital can help the world to become greener. And I think that is maybe part of the pet project I would like to cherish over the coming years. That's really what we should be working on. I hope this is, and I'm sure you have the same problem now. We have addressed it in our previous discussion.
Thank you.
All right, good. Anders, remains me to thank you very profoundly for this interesting discussion. We have had many discussions about the operational side, and we try to say get you off autonomous and off the floor into the free space and air, and let's fly this route together. Yeah, trying to bring Europe as leaders in electronics and HPCs at the same time, and looking forward to keep on working and talking to you anytime, Anders.
Definitely, and let me just take this opportunity to thank not only you but all of Excel for the help that Excel has been to EuroHPC in our time after autonomy. It's been really nice to be able to reach out to your staff to get advice on how we set up financial systems, how we do things, legal help, and the likes. It's been really nice. You've done it before, and it's made our lives so much easier that we've been able to get advice from you. So thank you for that.
Thank you. Very much appreciated, Anders. Thank you.